I'm glad to present our work entitled Investigating Preferred Food Description Practices in Digital Food Journaling. Prior research as well as commercial apps have sought to support several food and health-related goals. Broadly speaking, food journaling can be used to support more quantitative goals, such as monitoring calorie and nutrient consumption to manage diseases and weight, as well as awareness and mindfulness goals, such as to make healthier food choices in identifying food intolerances. Food journaling has typically been supported by technology through lookups to food databases and barcode scanning of food packages, with a focus on the nutrition information feedback. However, this can incentivize eating more packaged foods, and searches can be cumbersome, inaccurate, or unsuccessful. Various efforts have then sought to support more open modalities or input methods in order to make journaling less burdensome and more descriptive, such as taking a picture, recording a voice memo, or saving open text descriptions. Other efforts have sought to leverage automation to detect eating moments through sensors, as well as natural language and image processing to identify food ingredients in photos and open texts. Given the diversity of modalities that have now become available, as well as the gamut of devices people use throughout their day, we sought to understand how people would ideally prefer to describe foods when given more flexibility and under fewer technology constraints around recognition, accurate entry, and desire for recall. This understanding will enable us to leverage these varied modalities to design food journals which better align with how people would wish to use them. So to answer this question, we built ModEat, a flexible and lightweight cross-platform prototype for journaling on phones, computers, and voice assistants that supported different input modalities. The ModEat on phone allowed for scanning of barcodes, photo taking, open text input, simulated database searches, saving website URLs such as for a recipe, and voice memos. ModEat on the computer supported the same modalities, and the Alexa and Google Assistant supported simple conversations, such as asking to record a food description or to read the previous entry. We deployed ModEat with 15 participants that had a mix of quantitative and awareness food-related goals. They used ModEat for 2 weeks and answered a survey for each entry to detail the contexts are related to the meal. We also conducted interviews before and after deployment. Our analysis involved a mix of quantitative and qualitative methods of the interviews and participants' 1,008 food logs. Finally, to understand gaps between description and automated recognition, we further investigated how participants' logs were and were not interpretable by commercial language, natural language processing, and food image classification services. In analyzing food logs and interviews, we identified preferences and strategies our participants used in recording their foods and that revolved around different ways of describing granularity, specificity, amount, and context. In particular, this revealed a high variance in how they prefer to describe their foods, both between individuals based on goals and among individuals based on their foods and circumstances. Also, image classification and NLP services interpreted logs fairly well, but we observed missed opportunities in their outputs. I will now summarize some of our findings, but encourage you to read our paper for more details, such as how context was referenced in some of the logs. Participants varied in how granular they grouped food items. Most inputs were of single food items, such as 1 cup blueberry, but somewhat decomposed foods in their ingredients, while others aggregated distinct foods, such as main and side dishes. We observed that the type of input modality correlated with granularity levels, such as database searches tending to be of a single food item or text descriptions having more aggregated food inputs. This was aligned with participants' perception of modality use, such as P6 that said database search was most useful generally because it's keywords, so a lot of the time I put cutie tangerine because we have a ton of those. Conversely, participants would often view text inputs as useful for describing lists, such as P9 that said I easily put down multiple items at the same time in text descriptions. We also observed that participants tended to aggregate foods more often when eating with others versus when eating alone, perhaps suggesting that they tended to aggregate when in social situations where they wanted to journal multiple items quickly. Also, there was no significant impact of food journaling goals on granularity levels. Participants also described foods with different specificity levels of detail. even of foods aggregated in the same input. A minority of logs consisted of generic ingredient descriptions, such as dumplings. Instead, participants tended to describe foods in ways which were specific enough to distinguish from other foods or ingredients, such as chicken or rice. Other logs went further to describe varietals of same food, such as roast chicken breast. There was no significant correlation between goals and specificity levels. However, participants reported that a meal's circumstance influenced the level of detail. For example, P13 said that if you eat out and you're logging what you had, then more than likely all you can say is, I had Irish too, because I don't know what's in it. Participants varied also in whether and how they described food amounts. Some inputs had formal scale references, such as ounces or grams, while others referenced the numeric quantity. Still, others used non-standard measures that made sense to them, but might not be interpreted by others, such as small, big, or entire. Other descriptions reference brand package sizes or containers with variable sizes. However, more than half of the described foods had no amount clarification at all. Participants with quantitative goals were more likely to clarify amounts than participants with awareness goals. They explained that to get more accurate feedback, they would really need to inform the amount measure. Contrasting with participants with awareness goals that said it was easier to just describe the food. In regard to NLP services, food items were generally identified correctly, with about 80% of descriptive entries correctly being interpreted in returning relevant nutrition information for every food item. Only around 4% completely failed, not matching any of the foods or wrongly identifying all the foods. For example, P15 journaled 2 tablespoons salad topper, and this was interpreted as salad. Many varietal descriptions used adjectives to describe food names, which could lead to misinterpretation and ambiguity, such as salmon cakes or banana tea being interpreted as separate items instead of flavors. Interpretation was also impacted by specificity and amount description strategies, which we detail more in the paper. Participants varied in how they used images to depict their foods, such as arranging for aesthetics in clear amount compositions, use of stock images, or picture of packages. Food characteristics would typically be clear, but some pictures were of wrapped foods, empty plates, or unclear liquid substances. Classification services tended to correctly identify at least one food element in most images with clear foods, but some services mostly identified background elements, such as keyboard, furniture, and appliances, or food containers, such as bowl or plate. However, image classification services would typically ignore labels and words, such as the salsa types in this first image. Also, shape and color influence the recognition, such as this third image of a cheesy bites package being interpreted as beer or chips. Moving to what we learned from deploying ModEat, we observed that some styles of capturing foods were not precise and could include ambiguity or unclarity, which in turn can lead to challenges when reviewing data or reflecting on one's eating behavior. A possible way to mitigate variance and unclarity could be to implement conversational journaling to surface what was recognized and enable correction and incrementation. Such a system could then encourage greater specificity, clearer amounts, or further details to clarify ambiguities and diminish variance. On the other hand, methods aimed to address variance could introduce burdens to the already demanding food journaling domain. Allowing for flexibility or even treating variance as a design opportunity may be particularly beneficial for people with awareness goals. In this sense, interpreting past ambiguous entries could be leveraged to provide deeper reflection around circumstances under which the data was collected, potentially highlighting the social and cultural celebratory nature of food. Finally, we also observed an opportunity for classification models to be trained not only for recognizing food in text and images, but also identify contextual cues, such as references in text and background information in images. Even if not identified with high detail or accuracy, these models could help point for fun or personal meaningful experiences, such as surfacing restaurant names or household objects visible in communal dining. Further mining of information embedded in photo metadata or passively recorded, such as location and time, could further provide context to complement reminiscence and reflection for both quantitative and awareness goals. Thank you.